Assalamu alaikum warahmatullahi wabarakatuh. Dear student of second prep, we are going to solve questions for March exam revision. We have items. This is the second revision for us. We have questions on oscillatory motion, and they are belongs to Egyptian Knowledge Bank Nagwa platform. Okay, let's start with our question today. Okay, question number 1 says that a pendulum swings from left to right and back again. Okay, we will start from left here to right and then we return back again. The pendulum oscillates without dissipating energy. Okay, so there is no losing for energy. How does the maximum displacement left of the equilibrium position compared to maximum displacement right of the equilibrium position? Okay, we can mention that if we are talking about the energy that we take the energy from the rest position or the origin position at the center and return to the maximum point to the left, and then again return to the origin point and then return to the maximum point to the right. So the distance that we going in the left side or in the right side must be the same distance to achieve what we wanted to get, or making a maximum displacement, or we called it amplitude. So the right answer will be, we can say its maximum displacement to the right is the same distance as the maximum displacement to the left. So the right answer will be letter B. Okay, I think it's easy question, and you must understand that we must left to go to left or right at maximum point and lose all the energy and return again to get energy from the origin point, then return also again to the right position and lose all the energy and set at the other side or at the right and return to the origin point again. Okay, let's go into question 2. Question 2 says that what is the term for the distance of oscillating object from the equilibrium position? Okay, what we can say about, as we go away from the origin point, so we make what? We make the displacement away from origin point, or displacement, or we can say we make a losing for all the energy that we get at the right or left from equilibrium position, or we can say rest point or recharge point or equilibrium position. So we can move away to the left or right. We can say we make what? Displacement. So the right answer will be letter D, displacement. Let's go into question 3. Okay, question 3 says that pendulum swings from left to right and back again. Which of the following is the number of oscillations, not one, that the pendulum must complete to be in a oscillatory motion? In an oscillatory motion, we make what? We make any number greater than 0. So we can say we make a point to go away and return back, make to the point left and right, and also return back to the equilibrium point or equilibrium position. So the right answer will be at any number greater than 0. We can't count or stopping the movement that we want to make by the oscillatory body. Okay, let's go into question 4. Okay, question 4 says that a pendulum swings from left to right and back again. The pendulum oscillates without dissipating energy. At which of the following positions is the speed of the pendulum greatest? Okay, we said that we have maximum speed or maximum velocity when we passing through the equilibrium position or recharger point in the middle here in the center. So the right answer will be letter A. Okay, let's go into question 5. We have question number 5 says that a pendulum swings from left to right and back again. The pendulum oscillates without dissipating energy. How does the time taken to swing the maximum distance left of the pendulum position compare to the time taken to swing the maximum distance right to the equilibrium position? Okay, we're going to the maximum distance left or to right, so we take the same time in each one. So the right answer will be what? Will be letter C. The time taken to swing the maximum distance left is the same as the time taken to swing the maximum distance what? Right. Okay, let's going to question 6. Question 6 says that a pendulum swing from left to right and back again. Which of the following diagrams shows the pendulum at its equilibrium position? Okay, when we are talking about equilibrium position, so we mean that we are at the rest position or in the middle. So the right answer will be letter A. Okay, let's go into question 7. Question 7 says that a spring attached to wall is pushed until it reaches the red line. Okay, then it's released. The diagrams show how the length of spring changes after released. The spring oscillates without dissipating energy. The blue line shows the equilibrium position of the spring. Okay, how does the distance between the red and the blue lines compare to the distance between green and the blue lines? Okay, as we said that we go to the left the same distance as we go to the right. So if we are in the middle representing the blue line, so we will go to the last position of red line and return to the maximum position of the green. So the distance here between the blue and red is the same distance between the blue and what? Blue and green. Okay, so the right answer will be the distances of each of one are equal from blue to red or from blue to green. Okay, as this is the maximum point away from the equilibrium position, as and the other is the least point away from what? From equilibrium position. So let's go into question 8. Okay, question 8 says that a spring attached on a wall is pushed until it reaches the red line and then is released. The diagram shows how the length of a spring changes after it released the energy. Okay, the blue line is half the way or in the middle between the red and the green lines. Which color line shows the equilibrium position of the string? I think it's easy to understand now. The line in the middle will be the equilibrium position. So the line of blue color here is the middle between the red and the green as we move away from the blue to maximum point and least point away from the blue. So the right answer will be the line blue, letter C. Okay, this is the first group of our questions of Egyptian Knowledge Bank. We are going to solve a lot of questions. Please wait for these questions and study hard for items for the exam. Okay, good luck for you and I hope you enjoy these questions today.